In this video, we'll learn about direct variation problems. We'll recognize direct variation problems from context, from a table of values, from an equation, and from a graph. A car uses 8 gallons of gasoline to travel 240 miles. So assuming that we don't change the speed at which we're traveling, how much gasoline will the car use to travel 420 miles? Now we could solve this problem using a graphic organizer I call the rule of 4. And context is one of these 4 spots. I'll put it in the top left. I could make a table of values to represent the given information. I could put X could be my gallons and Y could be my miles. I am given 8 and 240 as one of my ordered pairs. I know that 0, 0 would be another ordered pair because if I got 0 gallons of gasoline, of course I would travel 0 miles. Using the given information, if I cut both of those in half, 4 gallons of gas, I'd travel 120 miles. If I divided those numbers by 4, it says for 1 gallon of gas, I'd travel 30 miles. And that's going to help me with my equation, y equals 30x. Because to get the y value from the table, I multiply my x by 30. Now to graph that, this is going to be a linear function, right, with a slope of 30 that goes through the origin. I can also, using gallons on my x-axis or my independent variable and miles as my dependent variable, I could graph the ordered pairs that are there and connect with a straight line. And so in this direct variation problem, notice in the context we have a proportional relationship. In the table of values, there's a multiplicative relationship that whatever x is, I'm going to multiply it, in this case by 30 to get y. My equation will be in the form y equals kx, and my graph will be a straight line going through the origin. Now let's solve the original problem. We can put 420 in place of y in my equation and solve for x. So to travel 420 miles, it would take 14 gallons of gasoline. So you want to be familiar with the contextual form, the table, the graph, and the equation form of a direct variation. Let's look at the tables more closely. Here, all of these tables represent direct variations. And in the tables that we see, y varies directly with x. That's one way to say it. In other words, the y value can be determined by multiplying the corresponding x value by some constant. So in the case of the minutes and the number of cookies, it looks like x times 3 equals y. We could write a similar equation for the other tables. Okay, now we'll look at the graphs. What do you notice about these 3 direct variation graphs? What kind of a function do you see? And is there a point on the graph that the function always goes through? Graphs of direct variations will always be linear functions that pass through the origin. Now we'll look at equations. All of these are examples of direct variation equations. And of course, if we graphed them, they would be lines that go through the origin. What do you notice is similar about the 3 equations? It looks like that they will always be written in the form y equals kx, where that k is what we call the constant of variation. Notice there will not be any y-intercept other than the origin. Now, speaking of constant of variation, that's a common type of task that you'll be asked to do. To find the constant of variation in an equation, it is what number is multiplying the x. To find the constant of variation in the table, what am I multiplying x by to get y? And in a graph, the constant of variation is going to be the slope of the function. So in this case, the rise and the run, the constant of variation is going to be 1/3. So let's summarize what we've talked about with direct variations. We know the graph will always be a linear function passing through the origin. The table will show a multiplicative relationship between y and x. The context will be proportional if it's a word problem. And if it's an equation, the equation will always be of the form y equals kx, where k is called the constant of variation. The constant of variation will be the k in that equation. It will also be the slope in the graph, or in the case of the table, it's the y value that corresponds to an x value of 1. So thanks for considering direct variations today.